stuff. Yeah, it's still usable for getting stuff, but it's not.
Hello, welcome to Desert Blockchain. This is the afternoon session on Saturday, January the 30th, 2016. We had a morning session, a mini conference, and you can see that on our YouTube channel. Just click below on the website and you can review that. We did have an abrupt ending to that morning session. I apologize for that. That was my fault. And we will make corrections for that in the future. So we're coming back from lunch. We got a great group of people here today. We've had some fabulous conversations, lively conversations. I invite you to review that on the morning session. Just so you know, this is an event that's happening on a quarterly basis. Our next session will be April the 30th, 2016, again here at Gangplank Chandler on a Saturday from 9 a.m. to 6 p.m. with a mini conference in the morning, lunch, and then come back with a team hack event we call a Team Hack Attack. We also have a monthly meetup, and you can go to meetup.com/desert-blockchain and tie into that and get updates on the meetups. And that will be towards the end of the month, generally the last Wednesday of the month, from 7 to 8:30 p.m. here at Gangplank Chandler. And the idea is to have hands-on sessions. From time to time, we do have outside speakers that pipe in via Google Hangout, and we invite you to follow along with that as well. So my name's Jay Carpenter. I'm the founder of Desert Blockchain. Thank you for your attention, and please feel free to contact me under the contact section at desertblockchain.com. So we've got some great people here today. We're going to kind of continue our conversation from this morning, and then maybe walk through a demo of one of the platforms, and then basically wrap it up from there. So anybody have anything you'd like to say? We can continue the conversation from this morning. Kind of what I'm thinking is that it might be valuable for us to do like a walkthrough of just a fundamental setup of multi-chain, or Christian, if you want to do a demo of IPFS, that would be awesome. But Linux had a question about how do you set up a private blockchain? How can you do this? Not only set it up, but also invite other people to participate. I think that'd be a great thing for us to step through. So it's basically, your event, and we can do whatever you guys want to from this point on. We had planned to have a team hack event, and I think we'll set that up for the next time on April 30th, and basically get some teams, or at least team captains, formed in advance. So any questions, any comments about what you guys would like to do this afternoon? Folks. So, Christian, you want to show us? Can you show us a little bit about IPFS, or would you like to show multi-chain?
What IPFS is?
Yeah, why don't we do it?
Multi-chain up here. Sort of the issue. And also, I don't know. I haven't set up multi-chain since the last time we did it.
Yeah.
6 to 9 months ago.
I'm a little rusty on it as well.
And I'm also hesitant to endorse multi-chain because of the fact it's still not open source, and his response is sort of all open source when I'm ready to, which is not the open source mentality. It's here's my code. How do you contribute to it? He's not interested in that.
Maybe he's shy.
Right.
Well, why would you be shy other than having shoddy code?
So, good. Harlan.
Yes. Write better code.
Welcome. Would you like to introduce yourself to the rest of the folks here today?
Oh, okay.
And tell us, a little bit about your background and what your interest is in multi-chain. Basically, what you'd like to get out of being here today.
I'm Harlan Robinson. I recently graduated of local boot camp. That's where I met him at one of the outings. I also know Elliot well, right?
Good to see you again.
You want to
I
sit
got-
over
I
here
got-
so you-
I got interested in the blockchain.
There you
Oh, I didn't know you were.
go. Yeah. No, this is-
Yeah, man, you're famous now.
Yeah, the entire world is watching.
3 people
are
watching.
No pressure.
I got interested in the blockchain when I was in Boston. I went to start up and the here. And they kind of like told me what it was, and I started to learn more about it. And it was just like always been on the radar, so I started purchasing it for $25 a week. You know, like 2 years ago. So, and so I've just, continued to learn, and I just want to, as a new developer, this is one of the things I want to get into. So this is, I see it as being the future of banking and finance, especially I like the social aspects of it as well. And I'm just going to learn.
Cool. Is there anything in particular you'd like to go over this afternoon? Any particular platforms? Anything you'd like to cover? We're talking about doing a demo on IPFS, but
Yeah, I don't even know what that is.
okay. You're not an expert on interplanetary file systems.
Well, if there's anything that you don't know what it is and you'd like to, then we could cover that.
My grandmother's one of the core developers. Anyway, cool. Well, thanks for joining us.
Okay, thank you.
All right.
Nice to meet all of you.
All right. So,
That might be sort of maybe want me to do like a quick demo of
yeah, that'd be
what
awesome.
the heck this thing is. So again, when we say content addressable, we are going to get extremely ugly hashes. This is what's called a multi-hash. The QM, I think it's actually just QM, pretty much stands for, hey, this is a multi-hash, step 1. Step 2, here's the version number, which means use SHA-256 to derive this. So this thing is proofed against, say SHA-256 fails, it's no longer secure. You can move to SHA-512 right away. All you do is change the way you hash your things and then prepend your hashes with these instructions, say, using SHA-512.
Yeah, there's one wrinkle there because I've been looking at that from Git. Git uses SHA-1, which you were just complaining is not advisable anymore. It's not fully broken, but it's not. Yeah, you shouldn't be building new stuff on top of it. So Git, unfortunately, I don't believe it's not using multi-hash internally.
No.
So there's going to be at some point we'll probably want to migrate Git to a new hashing algorithm. It's going to be kind of painful when we have to do that. So we'll have to handle hash equivalence at some point. And multi-chain isn't a solution for that, but it makes it a little easier to swap out different hashing algorithms within the same identity space. So.
And it depends on
So
what the hash is.
if I could
Yeah.
step back just a little bit and talk a little bit about IPFS, just in case people are watching this and they haven't, followed the conversation this morning. IPFS is a platform that is not specifically blockchain. Is that correct?
It's absolutely not blockchain, not even a little bit. It would be something you might build a blockchain on top of, but it literally has nothing to do with blockchain.
Yeah.
In a vacuum, it's just a big sort of file system that anyone can use.
Yeah, basically, it's a globally accessible file system. It's implemented on top of what's called the distributed hash table. So we have a whole bunch of computers all over the planet in the true, before they turn it into marketing speak, the true meaning of cloud. We don't know who's running these computers. It doesn't matter that we don't know. Anyone can add nodes. Anyone can remove nodes. The system is designed to work under those constraints. So as nodes get removed, existing data will be rebalanced to other nodes. If nodes get added, existing data again will be rebalanced to new nodes, so it's more available. And it's based off Cadmelia, if I'm saying that right. I think I'm saying it wrong. And Coral DHT algorithms, which they're pretty interesting if you look into how they're based on kind of ring theory and such. But anyway, it's a way of finding something. If I have a whole bunch of people that I don't know exactly who they are, and I need to ask for a piece of data, it's a protocol for figuring out who to ask for a particular piece of data. And so it's a way of putting anything and everything into this one huge shared file system that we all have access to, and any other person who knows the same name of that thing can ask for it and pull it back out of that system from anywhere.
So this is
I consider this to be a very revolutionary content management system. Would that be accurate?
I'd say
Yeah.
distribution, but yeah, it's pretty close.
Content
You could use
versioning.
it to build a
Content
CMS on it.
versioning,
Yeah.
et cetera. So this is a platform that could very well be very complementary with the blockchain.
Yeah. It's a dumb bag of blobs.
Okay.
It's like a transport layer. You stick in a blob based on its checksum,
It would be
and anyone else can pull it
ideal
back out.
for a blockchain distribution mechanism. Say
Yes.
I gave you my Genesis block and I gave you my head block. Those could both be IPFS hashes. And since the head block would point to the previous block and the previous block and the previous block, there'd just be more hashes. You just lock that tree and verify that it lands on the Genesis block and it followed the rules you expected. And if it
Yeah.
did, A-OK. And because you're accessing over IPFS, ideally, you're also distributing the assets as you visit them.
Yeah.
So distribute-
And
You know what?
So you give it the
Grandma Carpenter said the exact same thing when she was serving me my oatmeal.
so if you give it the first block and the destination, the source and destination block, and it can traverse all the blocks in between, almost like the beginning of the breadcrumb trail and the end of the breadcrumb trail. That's how you verify that
Exactly.
that it went through that. one
And
path.
that's blockchain / Merkle DAG. IPFS, like I said, best way to think of it like a magician's top hat. I can take this magical top hat
Man, we're getting really.
and I could put something in it,
Uh-huh.
and then that something, if I put a rabbit in there, and then you have your magician's top hat, or I give you the hat and you say, I want to pull out a rabbit, then you get that. If the rabbit exists in that space, someone's put one in there, you can pull it back out. And that's how IPFS works. It's just a way of automatically distributing any kind of blob. And you can put blockchains in there, you can put Git repos in there, you can put websites in there, any kind of blob. You just stick it in the key points of IPFS, you put in data, some kind of binary blob of data.
Okay, cool.
And if you know its hash function, if you know one of the hashes that refer to it, because it uses multi-hash, so it could be an SHA-1 or an SHA-2 or a number of different things, or some we haven't invented yet, you can get it back out from anywhere in the system.
So that kind of paints a picture of what we're playing around with. It's not directly blockchain, but this is likely very complementary with the blockchain technology. So, Christian, take it from there.
Okay, so to start with, I went to IPFS.io, which is
Yeah.
literally their main website.
That's the name of
It's
it.
not necessarily
Or
hard to
Internet
easy to
Protocol
remember,
file
but
system.
IPFS.io is short enough. You scroll down, there's an install button. You'll hit that. Now, if you are on Windows, as I imagine most people are, at least I am, and I've never done this on a Mac, so it may not work, but I think it will. There's a binary for Mac or Linux x86 or Linux x86 or Linux ARM if you're interested to put on a Raspberry Pi, something like that. But see, notice there's no Windows. If you just go gobuilder.me, it's all written in Go. They've cross-compiled it to a ton of platforms. Go is very good at compiling to separate platforms. So if you scroll, oh no, this is not where I was looking. You want to scroll to see all builds. Now you'll see in this chain, buried in this giant website, Darwin, that's Mac. You see Darwin, that means this is the Mac version. Now you can get that from the front page. Same with Linux, but here's the Windows version. It's a zip file. Now all of these are going to contain, and we'll do Darwin to start with, Mac OS X. I click that. It'll download. All of the archives look exactly the same inside, and you need one file. They've compiled it all down to one 6-meg binary on most systems.
It's the advantage of a compiled language.
Yes. So it just extracted it in a place that I can't really show you, but here, I'll show you.
Just as a side question,
Yeah.
does anybody here know the Go language or just have a good understanding of it?
I can read it. I have yet to write anything.
Okay,
Yeah.
but do you know like the pros and cons of it, or like why people use it and all that other stuff?
I can tell you about
so if you're not happy with the fact that Node is not compiled and you're not comfortable running JavaScript on all of your different boxes and you'd rather run compiled binary code, use Go.
Okay.
If
And you think
want
Java
C++
might sue you at some
writing
point in the future?
concurrency, sort of training wheels, Go is very good. If you want a paradigm that forces you to modularize the hell out of your code and use message passing, which is inherent to writing, in your code, use Go. Go is very good for that. If you want fault tolerant stuff, that's not built into Go. You want like Erlang or something for that. You can build a fault tolerant Go application, but it's not going to force you to. You could just build another. You can just build Hello World in it, just like you could any other language.
Learn Go before you learn Erlang.
Yeah.
Erlang's sort of dead.
Well,
Wait, what is it called?
I think I would
Airline?
say I know where
Airline
Airline
is
goes.
from Siemens. It's a telecom op
Did
system.
they buy it or
So
Sony
that-
Ericsson?
That's selling apart. Here's
Oh, it was
the
Ericsson. It was
directory.
Ericsson.
You're right. It's
Extracted,
Ericsson.
Yeah.
Where this is what it would
I
be,
got
just extracted.
Joe
So there's
Armstrong.
installed
was the guy.
.sh. I don't know what that is. It's a shell script. We're not gonna worry about it. And it's also not gonna be on Windows, so we're gonna ignore it. There's license. I don't remember licenses. I'm pretty sure it's MIT. There's a README, which is the same as the getting started part. Of this. Oh man. Here's the getting started page.
Well, you're finding the getting started page.
Or docs.
Um, There are a bunch of videos on IPFS that I'd recommend you take a look at. There's a fellow from Stanford, is one.
I think the Stanford talk, they had a nice short talk called Why We Must Distribute the Web that was a great short intro.
Show that.
Well, I think they pulled it off the homepage and they replaced it with the Stanford talk, which is over an hour, which is a better talk, but it's a bigger time investment.
Yeah.
Yeah.
So it's
Yeah.
worth watching if you're willing to invest an hour plus, and it really will get you some good knowledge.
Okay.
Okay,
Yeah,
so
all
getting
gives
to the usability up here. We have
IPFS.
IPFS, this is what the zip file would be. On Windows, it'd be pretty much the same, except instead of IPFS, it'll be IPFS.exe, whatever. You put it somewhere where you're comfortable running it from, which would be like, I don't know, your desktop right here.
The web.
So we're done with this, we don't
That
need
was
any
the
of
old
this other
one
stuff.
that honestly, if
Now,
you just watch
I'm
this
going
thing
to
to
go on a
talk,
terminal and
it
get
covers all the
command
same stuff in
prompts
far more
in
detail. But I
Windows,
like
but
that
you're
these
gonna go
guys
to
did
where
it
you
enough
put
because
the
it's
file,
a
in this
short
case, it's
talk.
on my desktop.
If you've seen some of
Now,
the
we're
hour
gonna
and a
try
half
to
talk,
run,
It's
now we have a
referred to
//
as
it's on
the-
any Linux box, you have.
As a Stanford
On
talk.
Windows, it would
it's
be
right on the page. If you go to
IPFS.exe
IPFS.io,
and then your
it's like the
command,
second
right?
video on the page.
Now,
It
on
says,
Linux
just-
and
I forget what
Mac,
it's
you're
called.
gonna
It's-
type
Jan-
./IPFS. There's no
Jan Bennett,
.exe
I think is the
binaries
guy
for
who did it.
themselves. You might have to
like a
also
couple
do
decades that she
chmod
did
755 IPFS, which allows you to run it as a console. We're gonna go do that.
Yeah.
If you run into any trouble, if you Google it, these are all really common things. They'll walk
This
you
is a
through.
good.
It's the
You
same
mean
process
the
for any
Linux
Linux box.
Yeah. It's the
Now,
other- it's
Normally,
the
what
other
you do with
person.
IPFS is you run it as a
Well,
daemon through the
next.
background. So
Hey,
it's,
guys.
it's participating in the network relatively actively. You don't have to run it as a daemon, but I recommend it because it's more stable and it actually benefits the network to run it as a daemon. You're not distributing the stuff that you are adding to the network, which is important. If you add something to IPFS but don't leave it run as a daemon, how is anyone going to retrieve it from you, right? You have to run it in the background. So we're going to IPFS daemon, and it's going to fail. It's going to say, you don't have any public or private keys yet. I can't run. So you're going to say IPFS. The first command you're going to run, and you're only going to run it once, is IPFS init. Now it's going to generate a peer identity, which is a hash, a multi-hash of your your public key. So when you sign something on the IPNS network, everyone knows, yes, this was in fact signed by my friend who gave me this hash. So we're going to go ahead and take this ugly, and see, you can see how ugly these addresses are. Like, ugh, gross. So you can put them in a QR code. It's the same problem as Bitcoin addresses or transaction hashes. They're just a digest of ugly amounts of binary.
And that's secret data?
This is not secret data. The secret data would be, here's the secret data.
It's okay if you don't have to show me.
No, I
Obvious
just want to show
reasons.
you really quick. Maybe not. So there's cat config. So this is your configuration file. If you scroll up, here's your one secret data. This blob, this is your private key. Notice it resembles very similarly an RSA key. That's because it is. It's actually an RSA key that tells you that when it's generating it. Generating 2048-bit RSA key pair. And if you're not comfortable with 2048, you can step up the bit to whatever you want. You can do IPFS in it, -B, 4096 or whatever. 2048 should be good enough. So anyway, we've initialized our setup. That basically says, I'm setting up IPFS for the first time. Please generate a public key that's always going to be mine and stored on this computer, this directory. We always know to find it. So now that it has that, it can participate in the network. It can publish things and it can talk to everyone else. Here's the IPFS daemon. Now it's going to initialize it and it's going to be running, right? Now it says gateway read-only servers listening on IPFS, or sorry, IP4 127.0.0.1 IP 8080. That's your port. So this guy has generated a README file and put it on IPFS network, so you can go to this, which is actually a URL, sort of. So if we go to, there's two ways to access IPFS, and one requires you to run it, the other one doesn't. We're going to start with the one that doesn't. So they have public gateways which allow you to access anything on the IPFS network because they're generous, I guess. They're gonna shut that down eventually, because you can just access whatever you want on it.
But is this still peer-to-peer, or we access?
Absolutely. Well, no, so
Are
when
we
you use a
accessing a
gateway,
server?
you are trusting that the guy
That's
running
the-
gateway IPFS.io is actually running IPFS, and he's gonna reliably give you that data. The hashing mechanism is lost here, because you're just using your
Right.
browser
Yeah.
to ask the server for something. This is
All
dangerous.
all the
You can't
security
trust it.
breaks down.
So,
But
but
this
still, you can use it to access things you're not that worried about man in the middle.
so this
So you
For
could-
example,
you
the
could-
stream.
This is a great way to play around with IPFS.
Yes, I'm gonna show you how to reliably do it too.
well this is a great way of getting people, if you use IPFS and you put a picture or some asset into IPFS that you want to share with normal people who have no idea what IPFS is, you can point them to a gateway link as a temporary measure so they can still access that content until IPFS is more available. And they're talking about building it into one of the major browsers. And at that point, you'll be able to go straight to it without installing anything.
So that just helps for user adoptability.
Exactly.
This is a huge
I can deploy a web app.
advantage to get this thing off the ground.
Yeah, and hopefully this does not last long. Hopefully
Right.
bouncing off a gateway
Well, here's
disappears
something
real
you can
soon.
do.
Because
So-
there'll be
They're
enough
putting illegal
adoption
content up there and start accessing from your gateway, they'll shut it down right quick.
Yeah, yeah.
That's the problem. They're basically allowing you to put anything you want on their network and allow you to access it from their server, and that's dangerous.
And so my problem with this is it's the same thing what happened with LimeWire with Nutella.
Yes.
Is LimeWire, I see the same potential where Nutella was a fully distributed protocol. LimeWire bundled an ad server on top of it, and everyone used that one.
Yeah.
So this same potential here. So I'm hoping this dies quickly.
This is a.
We're
a
gonna
nice
drop
gate.
this in
It's
about-
a stepping
About
stone.
15 seconds, I'm gonna show you how to do this in a secure way,
Nice.
using a gateway. So,
Oh.
we have, this guy says, now try running IPFS cat and this ugly monster. Now we can do that. I'm gonna go ahead and open another tab, right? You can't do this in Windows, but you can do it in most Linux things. But notice, IPFS daemon is still running. If you're on Windows, you want to keep it running in a separate command prompt. Don't close it, right? So now this is running, I can type /IPFS, which, should show me a bunch of garbage, just to make sure I'm in the right directory. Now, IPFS, I can't read, IPFS cat, which is just print out the raw data, right? And then we're gonna feed it an IPFS URL, which always starts with /IPFS, and then another slash, and then the hash and whatever else. So this is what he gave me. He said, hey, Christian, come visit this, come look at what I made here. IPFS, there's this on the README, and I hit enter. And it's gonna take a second, and then here it is, right? This is the README file he made. That's nice. Okay,
So,
this is
this
all
is-
terminal, which is really ugly to work with. Go ahead.
but this is this completely bypassing DNS? Or is this completely going peer-to-peer now?
This right now is using the IP4 network, but it can bypass DNS. If you put it on a mesh network, it doesn't matter because it knows that this ugly monstrosity of data identifies through SHA-256 secure hashing the tree that points to all the other things. So anyone I don't even trust can give me data on this, and if they're lying, the hash won't check out. And I'll go, you're lying, here's your data, put it in the trash, right?
So when you load up that URL, that hash, it's traversing up the Merkle DAG to verify
This is
the
the end of the
contents.
Merkle DAG. And then this is a child of it, and children can have names. So README has its own hash,
Uh-huh.
but rather than make it hash/hash/hash,
Right.
you can just have an ugly thing at the very start. And then from then on, you can just use the aliases whoever made the Merkle DAG gave it, which makes it usable once you get past the first ugly part.
So the README is the end of the Merkle DAG, like an alias to
So
the most
jumping
recent.
ahead real quick for you, I can do IPFS LS
Mhm.
and then this, and then drop the README, and it actually will work like a directory. There's contact and help and quick start and README and security notes, and you can put folders in there. You can do everything. I'm going to walk you guys through how to do this yourself. It's really easy if you're comfortable with the command line. You have to still be comfortable with the command line right now. Sort of. Actually, there's a web UI, but I don't quite trust it. All right, where the heck was I? I was typing this in. So here's the public gateway. Again, you have to trust that if they're running IPFS, they're not going to feed you bad data because your browser is not checking this hash. All your security breaks apart. This is a convenience layer. Any of you can go to this on your phone, on your browser right now. I don't expect you to type that in because it's impossible. And I'm going to hit enter. And this is just the README file. And check it out. There it is in my browser, right? Now, I didn't need IPFS daemon to do that. So here's how you get the security part, though. This daemon is running on port 8080 on localhost, which means it's not going to talk to anybody else except what's on your computer, so it's relatively secure. What you're going to do is you're going to go http://127001. If you don't want to remember that because you're not a networking guy, you could just type, I'm pretty sure,
Localhost.
localhost. Now, some machines this will fail for some reason. But 8080, right? Now you're talking to your local IPFS data. Anytime you ask it to do something, it's going to use IPFS to go get and verify your stuff. And then I'm going to paste in this README /IPFS/this /README. I'm going to hit enter. And so now it shows up, right? And now I can access it on IPFS. Now that may not seem like too big of a deal, but there's things that you can do with this daemon that are quite interesting. One, you can use your browser to access anything and spit out. So you can deploy a web app or a website that's never going to change, get a URL that points to that hash, and be done with it, right? Sort of like a static page. Another thing you can do, this thing, and it doesn't work on Windows, but it works on Linux and Mac, you can mount any hash on your file system like a folder. So you can say, mount this hash, and now you can visit it on your file system locally. I haven't tested that enough. I don't know how reliable it is. I would like to do a demo, but I don't remember how to do it.
Quick question on the website. If
Yes.
somebody makes a change to that website, I assume it generates another hash.
Yes, and
How-
I'll never visit it. Right. Someone, you'd have to give me that hash again.
So how do you get that? I mean, how do you get that new hash? I mean, if it's a newsfeed website, how do you get the latest version?
I'm going to show that later in the tutorial. I'm kind of doing this on top of my head. Make sure I do it, but I will.
Okay.
They use something called IPNS, and that's deeply tied in with, remember I did init? I said, here's your pure identity. Well, that's my public key. Anyone that goes to this, I've actually never done this, so let's try that.
So IPNS is an interplanetary name system or name server.
You're right.
Yeah.
It's literally just a directory of public keys identified by hash.
So it's almost like DNS,
This is not gonna work
IPFS
the way I
style.
thought it. So ignore the fact that it just did that.
Wait,
It's
is
not
it-
supposed to do that anyway.
I was gonna say, is it IPNS for that? Because you're trying to access
I
it.
don't have anything in my root. I
Oh.
just wanted to see if it would spit out my public key.
No, but it's like name server or name system.
Yeah, well, I'm just wondering if you're looking up stuff. Oh, anyway, I got to look into it more because I haven't studied IPNS enough yet.
So, I have showed you how to use the gateway, sort of like how if somebody gives you this ugly thing, how to access it. You can either use the public gateway.ipfs.io if you're not worried about a man in the middle, if you're not worried about reliable security transport, and if you don't really want to participate in the network, you just want to access the resources. As long as there's a public gateway you have access to, you can do that. I would not recommend it, but you can. It's sort of like ignoring the big, there's a little lock symbol in the top left corner of your browser and it can turn red. And if it means that, don't type anything important in because your encryption's broken. Anytime you're using a gateway that you don't necessarily trust, imagine that little encryption thing is red, because it is. But if you use localhost 88, you're saying, hey, IPFS daemon, go get this resource, this tree, and then give me this child of that tree and verify it all along the way. So it'll do that. He also he has other things. There's an about page. So if we go here, we go to the end of this, I can actually access about. And like I showed you in the console, I can LS stuff.
Oops.
This has failed miserably. I actually think I changed my hash.
Yeah, you
Anyway,
pasted the other one in there.
I don't quite know what even about, so it's not.
So the best way while you're struggling
Yeah,
with
see, look,
that,
they deleted the about page. It's still in the README, but it's not in the LS, so you can tell it was gonna fail.
Wait, how did they delete it? I thought you couldn't delete out of the.
So their README says, hey, visit our about page, but in the hash, there is no about page. So you go to the hash about, it goes, that doesn't even exist in the tree, what are you talking about?
Oh, so it's not like they created that hash
They
and then
had an
got rid
about
of it.
page at some point, and they changed the README and they changed the hash, and they didn't update their actual README text to say, we don't have an about page anymore.
How about pulling up the help?
Sure. There's help, we know help can work because it's actually in LS. LS is cryptographically it's cryptographically going to this tree, this IPFS root. Oh, dear God. Please go away. So it's going to this tree and saying, hey, tell me all your children, and it is. This is the hash. See how I said everything has its own hash. You don't necessarily have to use it once you have the root. So contact is actually, its hash is this, but you can access it using contact, and this is its size. It's 202 bytes, I think, 3 24 bytes, 1696 bytes. So before you go and retrieve an object, you can know how much overhead it's going to land you before you access it. So you said, let's try the help page, which the README does say to use. We'll ignore the fact that they can't it out. We're going to help. Does that work? It does. It's a really small piece of text. Okay, so we learned, and also, so this IPFS thing translates directly, like I said, to the terminal. I can do IPFS cat, which means just print it out and paste it. This same URL, no HTTP, no gateway, no localhost. This is just an IPFS URL. Hit enter, and it'll display it. So you can use this on the command line actively. You can use this in the browser actively, and you can use it to deploy stuff. Now, we're going to build an IPFS site, but to start with, okay, so we don't always need ugly URLs, right? So IPNS allows you to use someone's public, pure identity hash to go find their latest broadcast that was signed by their public key to get their root. What's more interesting is you can actually use the existing DNS infrastructure, if you care to trust it, to put a DNS.txt record in your DNS setup. It's a little advanced, but there's a tutorial for it. But IPFS has done it. So I can actually go to IPNS/IPFS.io. That's their website. And guess what? Here's hoping this works for Ray live coding demos. This should resolve their domain, find the text pointers, and get the hash. And now here's their website posted on IPFS. This is their whole website. It's on IPFS. And I'm actually, as I'm accessing their Merkle tree, I'm redistributing the Merkle tree for anyone else who asks for it. As I'm accessing these objects, these images, these pages, I'm getting them locally. And as long as I'm in the daemon, anyone else who wants it can go ask IPFS for it. They can ask me for it. I don't have any authority to change this, but I have the authority to distribute it, because as long as somebody has the root Merkle hash that this DNS pointer points to, they can go get it. Now, this is how you sort of bridge the gap of, okay, the existing internet is the way it is. It's not easy to change it. But you can deploy sites on here pretty easy with DNS changes and then make it abstracted. I took it off, now it points to GitHub pages, but I had my root domain pointed at a text record and an IPFS gateway. The gateway would resolve actively the latest broadcast and display my page, and all anyone's doing is visiting a .com domain on their end. But at the same time, I'm using IPFS to it. Now, what's interesting is you build your own CDN automatically. It's, jQuery. Everyone uses jQuery, and everyone uses CDN to distribute jQuery. Well, if we all just use IPFS, everyone could distribute jQuery all at the same time, and nobody would have to pay Akamai or all the other CDNs that exist out there.
Plus,
Amazon Web Services.
another key point, if you're referring to things by hash, the chances of someone injecting a corrupted, malicious version of jQuery are 0. And if you change the version, even by a tiny bit, then you would automatically go grab a newer version based on the hash, and then you just cache that locally for every single site that uses it. And so there's no risk of pulling down malware as long as the hash is valid and not malware.
For example, in China, there was on GitHub, there's 2 repositories they use to host ways to get around the Chinese firewall, right? These are open source projects. Here's a way to get around the Chinese firewall. Of course, China doesn't like that. So what do? Well, they usually use cyber attacks to try to take down the GitHub site. Didn't work. So what do? Baidu.com is their Google. So what they did was they changed the jQuery.js JavaScript little application that runs in the background to ask GitHub.com for a copy of this repository, sort of the root page, every 2 seconds on both repositories. And what happened, every single person in China was suddenly accessing this GitHub repo. What happened to GitHub? They went down.
Is that the one they're calling the Great Canon of China?
Yeah, probably.
Or is that a DNS
So
rejection?
basically all they had to do was just change the JavaScript that was served up behind the Chinese firewall. So everyone visiting Baidu.com was just making 2 requests to GitHub every 2 seconds, and bam, GitHub is down, and they succeeded in their task of getting rid of those 2 applications in open source.
And
Now,
that's
if they
what
were
happened to
using
GitHub a couple days ago?
IPFS or IPNS, anyone accessing that resource is now also redistributing it. Good luck taking it down, right? You have to attack every single person who's ever accessed it and made it available.
Did
So
that
this
Chinese-
is huge. Are you saying that this is DDoS immune?
It's supposedly supposed to be DDoS immune. It has not been tried and
That
tested.
that depends on your definition of
I would argue
So
it's likely
DDoS, yes.
almost-
DOS, no. There are still ways to do a denial of service, but a distributed denial of service attack like that is impossible.
Wait, going back to this.
So I would argue that it's probably, if I had to estimate how DDoS proof it is, it's like I found a torrent that I don't like people distributing on the Pirate Bay. I'm gonna DDoS that. Nobody can DDoS a torrent, or else they would be doing that right now.
Yeah.
There's all this pirated content out there that people are torrenting all day long.
Now, the one thing, have you
DDoS.
gone deep enough, Christian? Because I haven't in IPFS. This really is kind of a redo of Freenet, which has been operational for 15 years.
Yeah, there's
even
a
though
lot. There's a large number of projects.
the difference, though, Freenet was specifically designed to be censorship resistant.
This is not censorship resistant.
So-
It's also not secure. You don't put anything private in here you don't want to have. If I put a page up that had a signature set, I
Here's my
hate
credit
such
card
and
info.
such, and I sign it and I release it, and I say, oh wait, I don't hate such and such, I don't want everyone to know. Well, as long as one person has access to that, it's now available in perpetuity.
So,
for as long as somebody
so
wants
do
to
you know
it.
if this, because in Freenet, because they want censorship resistance, not even requesting, just looking for data
So it's not that way
causes
in
the data
IPFS.
to automatically spread and become more available?
It's not that way in IPFS necessarily. One, you have the gateway. Two, you can say, I want to actively garbage collect every single thing I get every second. And then you just,
Okay.
then you're just a leech is what they would call it in the torrent world.
Okay.
All you're doing is getting stuff, but you're not redistributing it. That's not necessarily bad. If everyone leaches, it fails miserably. But as long as everybody doesn't leech, it's okay.
Going back to that China thing, did that happen like a week ago? Because I know GitHub
no,
was down.
GitHub actually had internal issues.
Okay.
The China attack a year and a half ago, 2 years ago.
Sounds about right. I don't remember all the details.
Anyway, so that's why it's sort of exciting. It's your own CDN.
Yeah.
It's sort of DDoS proof in the same sense BitTorrent is DDoS proof. And hey, you don't need any authority to host anything. I can add whatever I want anytime I want, as long as I can get the hash to somebody. And there's at least one node to copy the data. They have my website or they have my file. For example, we're going to do like a little bit of like an inception thing. I have IPFS on my desktop. Let me just change that up for some reason. I can do IPFS add, and I'm going to say -w, which means wrap it in a directory. IPFS, right? I'm just doing this to the binary. Okay, it's 24 megs. Now it added, here's the IPFS binary. Now remember, these hashes inherently have no name. They're just blobs of data. But because I put -w there, it wrapped it in a directory. So this is its directory. If I go here, and I visit this site, well, this hash.
Which under the hood is a directory.
Look, there's IPFS, and if I click it, it downloads, right? And anyone on the internet right now can either use localhost or gateway.ipfs.io/IPFS/that. They'll get this directory listing, and they can click that and download IPFS from me the way I published it, right?
So where does putting in the root hash come into play?
So here's where it gets ugly. If you don't wrap it in a directory, the root hash becomes that file, right? It's still the same actually as this. You notice that it's deterministic. It's the same hash. If I visit this, it is the parent. It has no name. Its name is blah, 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 right? It's
Right.
just this garbage. If
Like
I
it'll
enter-
start downloading the
It'll
file.
download it, but look what it downloaded it as. It downloaded it as QM blah 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 blah. Right? That's trash. Nobody wants to download files that look like that. So instead, we wrap it in a parent directory, right, to make it nice. Now, I'm going to walk you guys through a quick website. I'm going to try. I have not practiced any of this, but I've sort of fooled around with it. So on my desktop, you see I have my directory. What to do? And inside of my directory, I already have it open. I have images, Bitcoin laws of the universe. And I click this. I actually showed this image earlier in our talk. It's like basically Elliot spiel on how secure cryptography is. It's this big image which tells you, imagine you built a perfect computer and you're trying to just count to 256 bits. It's just not feasible. Anyway, I like showing that when people are like, I don't know if I trust the crypto. Well, if you can trust that it's implemented in the right way, there you go. So here's my website, sort of. And if I'm on my desktop and it's in this folder called My Directory, I can do IPFS add my directory. Won't work because it's directory. It says I don't like to do that. You say -r, which is recursively add everything in this directory. Go to my directory, add it. Everything inside of it, add it. I hit enter, it added all of it. And see, my root is actually my directory. I mean, there's a /images, which has nothing in it, and the Bitcoin laws universe. If I go here, this is the root hash, which is the last thing it produces. Like I said earlier, I think to you, or you,
Probably.
Starts with the children and works its way up. First, it added directory Bitcoin laws of the universe. Then it had directory images, and because those two are siblings, they're independent of each other. But this root hash depends on them, so then it made that, which contains these two. If you don't do it in that order, it's impossible to build the Merkle DAC because parents have children, you go children, 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 parent, root node, and you're done. Anyway.
So it created my directory first, then it created
Right.
the
Now,
five.
under the hood, I mean, to make it nice, you just make a regular directory. Heck, this is my website, right? And then I do IPFS add-r, it'll take care of all those details for you. Spit out this root hash. So here's my root hash. And because there's no index page or anything like that, it's just going to be a directory listing like such. Here's Bitcoin Laws of the Universe. If I click that, middle mouse does not work on this because it's not a Windows machine. Okay, Bitcoin Laws of the Universe, I click it. And to it displays in my browser, no problem. Let's try something else. Let's go to, remember I said you can do it in the public gateway? I don't really care if somebody goes in and changes the words of this or doesn't even deliver it. And this is kind of a risk. It depends on how connected Gameplink is right now. We're going to go gateway IPFS.io, IPFS/this. So I'm not accessing this locally anymore. I'm asking the IPFS servers, and I think the closest one is Los Angeles, for this resource. I hit enter, and it's going to take a while. Their servers are massively overloaded because they're able to rehost everything.
Yeah.
And
this is a great opportunity to talk about why eventually if everyone transitions to something like IPFS, whether it is or something different, instead of having to go and bounce all the way to Los Angeles for data that you have locally, we could see that, oh, the data is right here in the same room, and we could pull the data from the closest node rather than having to bounce to whatever the servers are.
If you guys went on your computer, ran IPFS, and got this file, and then you ripped the cable out of the router that connects it to the internet, we still have our local network, and if you guys want to access this file, as long as one of us has a copy of it that's running the daemon, we can access that file or that website, anything like that. So here's that, and this is neat because I'm not hosting this anymore. Gateway IPFS.io is also hosting it. You guys can go on here and go get it if you want. In fact, to make it easier to type in, here's a QR code. If you scan that with your phone, it'll pop up a browser that goes and gets that image, right? So it's still sort of ugly to hand that off. Imagine you that hand this ugly hash
I'm gonna
to
try
everybody all the time. Be crap, especially because, oh, I made an update to my website, my hash changed, I need to print the business cards and hand the new hash business card and throw away all the old hashes. Totally wasteful, not user-friendly whatsoever. Now, we saw IPFS.io post their site on IPFS at their domain, which actually points to their public key. They can change their website whenever they want, because all they're doing is changing their public key's root signature. They're signing a root hash saying, I want my domain, I want my public key to correspond to this hash right now. And in the future, they can sign something else. As long as you trust IPFS.io and the things they sign, you can go visit their website and it'll update whenever they want. We're going to give an example of that. I'm going to build this website out a little bit more just to show you that you can build a web app in this. If I go to my directory, so now I'm in my directory, I'm going to make an index.html, which is the root page for most static websites.
This is a cat video.
Here's hoping that the guy works, it probably doesn't. Okay,
Oh, it is?
Just kidding.
no. That's one of the first. So here's my
Thank you for
index.html.
joining
I'm
the
not-
botnet.
I'm not going to live code very much off the back of my hand, but I'm going to do image source equals, and we're going to go ahead and point to Bitcoin laws of universe, and I have no idea what the extension is. So give me a second. Actually, I guess I do. If I go here, it'll show the rest. That's .jpeg. So .jpeg. This is an extremely basic HTML site that actually is not well coded, but it will work. So I quit it, and here it is, index.html. If I open this in my browser, just locally, I'm just going to open Firefox. Let's just try it. Okay, so this is me visiting index.html right now. Oh, I guess I should just to show it's different. All right, testing my VI skills. Hello, world. All right, so I just made a website that says hello, world, and then has that image below it. And if I refresh here, this is just my local thing. This is not my IPFS. Oh, there's me saying hello, world. Here's the image, which I'm able to reference, no problem. This is local. So now I'm in my directory. Now, if I want to make this a website that anyone can get to, and they can see my hello world, they can see my image, I can do IPFS add -r my directory, right? Just like we did before. Now the hash has changed, right? This is a new hash, and I have to get everyone out this new hash to my website. But if somebody visits this, we'll do it both with, so we have gateway at ipfs.io/ipfs/ and then here's the hash. This is my website. This might take a little while to load, so I'm going to switch over to my localhost version. So this is me also accessing on my local node. Again, this is the secure way, the gateway to trusting the gateway. So I hit enter. Hello world, image source, Bitcoin laws, universe. I don't quite remember how to get this to display as not text.
That's okay. We get the idea.
But anyway, you get the idea.
It's
There's,
awesome.
I think maybe you have to do index.htm for IPFS gateway needs to know that it needs endurance limit as text/HTML. And it's not doing that. I'm not going.
Yeah, does it mess with the HTTP headers at all, like the content
Exactly.
type?
Yeah, it's up to the gateway to decide what headers to pick for that file type. And you can change that in the Go programming and issue a pull request to say, hey, .xml should issue this type of header when it's requested, this MIME type. Okay,
Right.
so let me try that one more time just with HTML, and then maybe we'll get lucky. Notice the hash has changed once again. It's drastically different. QMRVM was QMTC was our old one. Now it's QMABS, et cetera, et cetera. So we're going to try this one more time and hope index works the way we hope it to.
Is there a parameter?
You're killing me. Well, so index.html will work if I just click it.
And that's a configuration of like the HTTP web server that
Which is
that
built into Go, which they leverage to serve the local gateway. And
So that
there
can
is a
easily
way
change.
to make it serve index as the root as soon as you visit it. I've not played with it enough to know what it is, but it's totally doable. So that was my local host, copy right there. Here is, look, it's on IPFS gateway. I can go to index.html, and it's going to take forever to load that image. Here's the problem. They only have so much space in their cache. So gateway.ipfs is a public one. Everyone's accessing it. And so I gave them that giant image, and they just threw it away as soon as they served it because they need to make more room for everyone else's stuff.
How do the servers know about each other? Like if you have like a
DHT.
DH what?
The decentralized hash table. It's the same way BitTorrent swarming works without a tracker. So if you Google decentralized hash table or distributed hash table, this thing uses what's called a Cadmilia implementation.
So
There's a bunch of them.
it's a variant of the ideas behind Cadmilia and Coral and a few other new
Now, this
ideas.
is old. DHTs are old tech.
Yeah.
There's new implementations, but DHTs
Yeah.
go back to
And
the
it's
90s.
primarily access pattern optimization. So you think of all the things
So it's-
like linearly, but then you wrap it around so it makes a
as
ring
long
of all
as
the
you
computers.
can find a bootstrapping peer or a set of bootstrapping peers, you can ask them for more peers and they'll give you
Yeah.
more peers. You can make sure you're talking each other's protocol. And if you ask them for data and they feed you garbage data because they're evil, you can verify it's garbage data because you have the hash of what you're requesting. And you can say, I blacklist this peer because he's feeding me garbage. He's a bad node. Right? I don't tell everyone else about him, and then we knock him off the desk.
So it's community driven updates to that table. Like if a new server is introduced,
It's a very in-depth concept. I would suggest you Google and Wikipedia.
Yeah.
It's old school tech. Lots of new implementations. But Cadmilia is tried and true. Anyway, so I have built this website. But notice every time I have changed this website, the hash changed, and I have to give someone a new business card to my website, my terrible website. So here's my current hash, right, of this website. Now I want to give everyone else this. So I'm going to do IPFS, oh man, name, publish. I really don't like the command that they did. Name, publish. I think I just paste, I have to preface it with IPFS. I am not a fan of their command line implementation, the way they do their commands, but it'll work. And if you forget, there's docs and there's a --l flag and all that. Did I get it right? It's a miracle. I got that right. So notice how I said publish to QMR8 UX blah 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 blah. Right? That means I took my private keys, signed it, and now anyone going to my public keys hash on the IPNS network, which is a different URL, will go and get my published site. Now, let's see this. This is QMR8U. Let's see when I init it, if I still have that in here. I don't think I have it anymore. I think I did in the other one. Give me 1 second. QMRAUXAF, that's my pure identity. Everyone talks to me like that, and that's a public key, that's a hash for public key, so I'm signing it. So I've now published this. Anyone who wants to go to my website that I published, my pure identity, which should never change on this computer unless I delete it and generate a new one. So IPNS now, because we're accessing somebody's name server, sort of addressing that, and then I punch in this hash would spit out, which it says publish to QMR, yada, yada. So we're going, this is the gateway IPFS, which I don't want to use right now, it's going to be slow. So IPNS, yada, yada, yada. We're going to go to localhost. Hit enter. Now, IPNS is, in my opinion, and at least in my testing, terribly slow. I'm not a big fan of it. I mean, even notice I accessed IPNS/IPFS.io, and that still took 5-6 seconds to load. So just requesting, did this beat me?
Well, if that's
Holy
the
crap, this beat me. So the public host beat me compared to my private one for some reason. But notice, anyone who accesses IPNS and my public keys hash now has my site, right? Hello world, and then it'll load this image eventually.
if IPNS is the DNS version of IPFS, where do you put in the host the
Domain?
TLD? Like where do you put in
I
the?
will show you at the end.
Oh, okay.
Not at the end, but like, okay, so here's this. Now I'm going to demo and show you real quick. If I'm in my directory and I go to index.html and I say, go away from that garbage, apparently I'm in the wrong directory.
It's near the index.html.
That's right. Should use tab. What am I thinking? So hello world, and then I updated my site. Updated site, yay, okay, now I want this new stupid hash, right? So we're gonna do IPFS add my directory because we're making another set of changes. And you'll notice some of the hashes haven't changed. For example, Bitcoin laws in the universe, this hash that it corresponds to has never changed this entire presentation because that data has not changed. Anyone that wants that image gets it from that hash. If they want to make a website that links to that image, they'll be using the same hash I am and distributing the file. So if this image goes viral, we're all distributing the load to access this image rather than picking one CDN to host jQuery. We're hosting jQuery on my site. How about we just host jQuery on everyone's site collectively? We can all trust it as long as we agree on the hash. Anyway, so I added this. Here's my new hash. Damn it, now I need to print out my business card and reissue it. No, actually not, because I use my IPNS. Now I can do IPFS name publish, and then I want to publish in my root. This is my new root. My directory is my new root. Oh no, I misspelled publish. All right, so we're going back to publish. Get enter. I know. Okay, so I'm publishing again. This is, look, publish to QMRAUX, so that's still the same hash. Just load the and then there's QMPHX. So this is the new hash that I had that I'd have to reprint, but I'm not going to reprint it. I'm actually just pointing everyone to my IPNS hash. This has not changed at all. I just said this is my new hash, signed it, and sent it up to the network, and now everyone knows who wants to look it up. So if I go to IPNS, actually if I just, so if I go to index here on the public gateway, I go here, this is really asking for trouble because it takes forever to update. Theoretically, when I change my root over time, it'll get broadcast and distributed out to the network so anyone else looking at my public key will find the latest copy and be able to access it and say, hello world updated. Updated site, right? This did not change. The hash is still the same because I'm allowed to change what my root is under IPNS because IPNS just points to what I signed last. So you sign something by using IPNS name publish and you point it at whatever point you want. If I wanted to, check this out, IPFS name resolve, IPFS.io. This is asking for trouble, but let's try it. So actually, when I go to IPFS.io's IPNS, this is what the object is that I get back right here. So if I go, if I go to IPFS, see, I'm not accessing IPFS.io right now. I'm accessing the root by addressing it what its current is. They can never change this because I'm not using IPNS. This is gonna be this copy of the IPFS website until the end of time, as long as somebody has a copy of this revision of it, right? But because I did IPNS name resolve, now I have their object. Look at what I can do. So I gave you guys all a copy of my root. If I do IPFS name publish, and I steal their hash, here's hoping it works. It actually probably has to go get the whole.
Doesn't make any sense. So you get, wait a minute, so you get a hash of the same value, but the contents will change internally?
So an IPNS hash is a pointer to a public key, and it'll say whatever the latest thing this public key signed is that root. Whereas an IPFS hash is, this is a hash value that represents this whole tree, it's never allowed to change. So what you do is you change what your IPNS root points to, you just change what IPFS points to. If you have NS points to FS, NS is allowed to change which FS it points to.
So,
FS can never, ever change.
so to get really, not technical, but to make it clear, there's two different concepts in computer science, mutability and immutability. And so IPFS only handles immutable data. When you put something in there, it's checksummed, that blob goes into the system, gets distributed in the DHT. That can never change. It can drop out of the DHT if no one keeps a copy. If everyone drops their copy, it's now gone from the DHT permanently. But that thing can never change. The data, if I don't know if it does.
So it's like a GitHub commit.
Yes. Sort of, but it doesn't necessarily point at a previous
kinda.
one. You can make it point at a previous one if you get fancy in the command
So,
line.
well, not an IPFS. That one checksum only points to that one piece
That's
of
not
data.
true. You can point to previous points of data using IPS object patch. See, IPS object patch, here's the name I want to give it, here's my root, here's my pointer to it. That's how you can build a blockchain out of this. You can always point to a previous block, which is.
Wait, I thought that's what you were doing the whole time. Like each one of those hashes internally is pointing to like some other
Right.
hash, like
so
the
if I want to
Merkle
make a directory by hand on the command line, it's a nightmare. You use that object command.
Right.
You say, I want a blank directory. Okay, I want this blank directory to contain site 1. I want site 1 to point to this hash. I want site 2 to point to this hash. Those can be all the revisions I made of my site in order, if I wanted to.
Yeah, but now let's not.
Now you can,
Because the Merkle, you can build a Merkle DAG within IPFS, but it is not necessarily one. It is just, again, it's a bag of blobs referenced by their hash.
and the blobs could be
That's it.
raw data, or it could be a tree, which is actually just raw data, just
Yeah,
raw
okay.
data.
Raw data with a
So
certain format.
so if you get the gobbledygook that's ahead of a tree, you can keep changing that tree, you can get the latest version, but if
So
you,
that's the
but if you go to one of the
you can
nodes of the
change the
tree,
root.
then that's immutable.
Yes, and also the NS points to an immutable root.
Yeah.
And I can just change which immutable root I point to. So for example, this was, when I did name resolve, this is the immutable root that IPFSIO points to.
But you can't really tell from, see, the problem I'm having is that I have to have it of looking at a URL and I can sort of tell what the hell it is or what it's giving me. With this gobbledygook, I have no idea what
So
the hell it
again,
is.
like I said, you can abstract away.
Hang on a second. Let
Am I
me,
making sense?
now, wait a minute. So when you say I look at the URL, there's a lot of trust in that statement, and it's not well founded. So you are trusting that the person who put it there, the thing that you're getting was put there by someone non-malicious, and yes, it matches up with the path name and all that. There's nothing guaranteeing it, and that's how malware works.
Right, of
Is
course.
we throw something malicious there instead. So you actually have no idea what you're getting. You have an idea, you have a conception of what you think you're getting, what you're hoping to get,
Exactly.
but zero guarantee of what you're actually getting. This,
But that's a separate problem from
But it's
understanding
a
what
bigger
this big
problem.
long string of gobbledygook is.
so and we'll get back to that in a sec. I'll let him take it from there.
So
But
notice-
this allows you to mathematically know exactly what you're getting.
Fair enough.
It's not
If
human
you're
friendly.
if you're accessing an IPNS root, you have to trust that guy's public key
Exactly.
to only sign non-malicious stuff. If you access an IPFS root, as long as you trust that tree, it'll never change and you can always use
Yeah,
it.
so-
But you can never always trust an NS root unless you trust the guy who has that
So
key.
is there such a thing as, let's say, because right now in Windows, I can point to any file, right click and get the properties. And tell me where the hell it is, what it's got, what the hell is inside.
So
Now, if
here's,
you give it something like that, I give it if I can find the properties of the big long gobbledygook, then I have to really have
so
it.
the properties of this is literally, this is, where is my mouse? QM this is a SHA-256 hash. And BDA yada 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 is the SHA-256 hash to the Merkle tree. You don't want to know what's in that gobbledygook, but if you want to access it like a file system, you can do IPFS ls list and then paste the gobbledygook and preface it with IPFS because you want to tell it, I want IPFS, not IPNS. Bam. This will list the contents of their site. If I want to look into their blog, I can type /blog.
What does ls do if you do it on a blog, not a directory?
I am not sure, but we
Try
can try
it.
it.
Let's see if it grants
So
you
you're
a
starting to
error.
understand what I'm saying.
It'll either degrade and tell you it degraded, or it'll list under the hood. IPFS actually stores objects in 256 kilobyte blocks by default.
Yeah.
And so there's actually a Merkle DAG within that object.
Yeah.
To I don't know. It doesn't work, right? So there's nothing under RSS.exe.
Well, no, if you grab the actual, can you grab the checksum for that object, not through the? I know I'm asking.
No, you have to go to the Go.
I'll try it on my machine. 'cause
You
I'm running
have
it,
to go into the Go code and figure out their multi-hash.
Enable,
Nobody's done that
Can
yet.
you enable Bluetooth on there? I'll send you a link. I inserted
I
something
have
at the beginning of
absolutely
your
no
talk.
idea. Here's
Just write that down.
Bluetooth.
Oh, I think I get it. So basically, because that first hash is a directory, and you put in like a human readable name after that directory, it uses that hash to look up that directory contents, and then inside that directory contents, it resolves that human readable name to its hash. So you could technically get to the same file using the hash of the file,
Let me see if I can.
that root hash / that file's hash,
Yes.
or you can do the same thing with that root
Right.
hash / that file name.
Now discovers Mofo. There you go. I'm gonna put that over here so I
So
don't see it.
is it?
So to break it down for you, just like what you're explaining there. Here's my root hash, and this is the root hash of the IPFS IO website. This is their whole website. If I go ls, I can go into blog and ls that because it's a directory. That's fine. These are all separate trees, right? The blog tree is actually this, right? If I go to this hash,
Well, no, go to that first hash / that hash, and it'll still bring up the same contents, correct?
Yes.
Okay.
but so I can, this is actually its own tree. If I visit this, it'll display everything in the blog directory, but not know anything about its parents because there's no link to it. But if you go to this root hash, it knows about all these children. So as you dive down the tree, you know less and less about the data behind it, sort of. Because of the way Merkle DAGs are built, you start with the children, you have their hashes. You build a parent that has children with siblings, that's a hash. So you have siblings can all be generated side by side, and then the parent has to be generated after the siblings. Anyway.
Yeah, but see, the thing is, what I was worried about is that you have to have some operating or knowledge of what this long string gobbledygook is.
So here's where it gets easy, and I showed this earlier. I can do IPFS or IPNS at any gateway. This could be a public gateway or my local gateway, and I can type in IPFS IO. That's their website. They've tied their IPNS hash to their domain using DNS. So all I have to remember is to go to the IPFS IO IPNS site. It's still more gobbledygook than I like, but that's human readable, other than localhost part. So how do they do that? Let's try to see if I know my commands here. DNS lookup, or no, it's NS lookup on Mac,
Or dig.
and I want IPFS IO. Dig is probably the better thing to do. I think I need
Dig is
dig
installed.
plus X.
You might have to make the window bigger to see all that.
Yeah, see, that's the problem. Like under Windows, you have a GUID.
What?
A quid.
They have command line utilities as well.
What?
You got it.
For what? For what?
No, I'm just saying sprinkle all throughout Windows. There's a GUID GUID, right? Of all kinds of stuff you can use to do that. But you can't really tell, like,
What?
no, just to be able to say, what is this thing? What, how.
Okay, but now let's be really clear though. When you say what is this thing, what do you mean? Are you talking about getting metadata on data?
Yeah.
Because that can be bolted onto a system like this. And there's this issue of cryptographic verifiability that systems like IPSS or things that
And
work
that's
off
in a
Merkle DAGs or
TXT
content
attribute?
It's a
addressable.
TXT
Give
address,
you
and the
that you
raw
do
thing
not
that
have
they put in there was
Yeah,
literally
at all.
I understand that.
DNS
But
So-
what I'm saying
IPFS.
is there
Now,
a way you
any
can-
native
delete
IPFS
some
client
data?
in Go will use the local domain name server client to go,
If you,
hey, go tell me about this domain and
So
see
you
if it
have to
has
put it
any
somewhere.
text records. It does? or any of those
So
DNS.
it doesn't
nodes,
automatically
this is the
store. You throw a
syntax they
blob
use.
in there.
It finds that and
stores
knows
it by
this
hash.
is what I need to resolve to access this
But
domain.
there's no
That could be an
provision for
IPFS
storing other
route.
stuff in there. You could
Notice that they use
metadata in the
IPFS routes
first
and
whatever
IPNS
section of that
because it's
blob.
more stable. DNS does a better job propagating than IPNS
But
right
right
now.
now, there's no. But again, you could have.
But yeah, that's how they do
some
it.
way
That's
of
how you can
finding
make your
blogs
domain
metadata.
actually hosted on
That's somewhat of
IPFS
a separate
in a
issue. So you look at that, but
relatively
you have to
user-friendly
source.
So
So in a
so
Windows thing,
using
you're trusting the
IPNS
OS
natively
is
doesn't
it's not
support
a safe assumption.
human readable
So you're
names.
getting
Like
data
I can't
No,
register
they're working on stuff
apple.com
like
in
that, but there's like
IPNS.
projects
So
like,
I'm trying to say, well, I
Namecoin.
trust this, I can
It's
see
starting to
this.
support Namecoin. They haven't
It's a
finished yet.
false thing.
There's,
It's false trust. You don't
DNS
actually, you might have
chain.
malware that's
I think he's working with the
modifying that.
IPFS team to sort of
Well,
do it that way.
DNS chain is
Rootkits
now,
get in there and add kind of stuff, so you're not
Yeah,
seeing
that's
what's actually
Is it?
there.
So
I
it's
didn't know
really
that.
bad
That's
depending
cool.
on-
or no,
So
they're
this
merged
is
into one.
more
Okay.
reliable.
Anyway, so they're working with
Yeah, this is
blockchain
more
sort of
reliable.
community guys,
Uh-huh.
the Bitcoin, Namecoin, DNS chain, those are guys all interested in blockchain, using that as a mechanism for Nate.
And I say,
that you
you
can
should
hinge
look
an
at this data,
IPNS
it's
to
not
start to get
malicious.
user-friendly
If you
names.
trust me,
Now, as a way to
then
just
that's
make
good
it
enough. You don't
immediately
need metadata.
implementable, they've
if the
also
trust
made
comes
it
to
so
me,
you
then I'm
can
not gonna
use
send you something
DNS
Right.
as
You
we
can
have
now
it
check
today.
against the
And it's
check.
using
to make
the
sure
native
it's the
DNS
thing I told you.
client
So if
under
you trust
Go.
me, then you can trust
Go
me.
just
If you
says, hey,
don't trust me,
operating
you should
system,
download it anyway.
ask the DNS this
Regardless of
question
what
and
the
see what the
metadata
text
is.
record is.
So IPNS resolves
Yeah, so
the
mathematical
public
consequences
key
is
hash of the server
So the stuff
to
that-
Not the
what
server.
people are
Or-
used to not
So the
having
hash
any
is a
kind of
copy of a
verifiability or
public
trust.
key. I could, if I
So
copy
they
the
have these concerns
private key
because
over
they
to my
realize that they
laptop,
have
I
no
can
trust
publish
now.
on the IPNS
They don't have
Right.
anything.
If I copy to
This
your
is
computer,
huge
you can publish on
improvement.
the IPNS route. And
It
if
is
any
a
of
little
us
bit of a mental
can
leap if
sign
you
a
don't understand
change
cryptography
that
to
goes
see
into
how
effect,
why
and now our IPNS
this
route
is
points to
preferable
that.
to the current state.
right. So it takes one hash and points it to another hash. Essentially.
Yes, and that's all it's allowed to do. It's literally only allowed to store one hash. That's all the data the thing stores is just a pointer.
So, yeah, we need to get some lapel mics, not just for this, but for all the conversations, because it does a lot better than you have
No,
to-
sorry.
Yeah, I'm actually building a thing where you'll actually look for whoever is talking the loudest. They'll just point the
Skype has
camera
something
to
like
it.
that.
You know, if you did a little microphone array, that'd be really powerful to pick out all the different streams
Well,
and just cut them
yeah,
into
that's
data
true.
streams.
Well, make it
That'd be
Somebody,
a hell of a product.
somebody associated with Cahoots
Yeah.
has come up with a
Crowd mic.
crowd, well, where you use your phone as your microphone.
Yeah, crowd mic.
Yeah.
So an even
That's
better,
awesome.
more technological idea is like there's a thing called Shot Finder. It uses an array of microscope or microphones.
IPFS is now following us.
That's cool.
That's awesome.
Crowd
Be the
mic.
high-
Good.
I'm like,
Hey, if it was a Juan Bennett, if he's watching, come on out to Phoenix. We'll have you out to talk.
Yeah.
That's right.
If you're
I was
ready.
going to reach out to
No,
him.
This
seriously.
is actually a project
Seriously, I
I'm
think we
working
can
on.
get one, Bennett, to.
I would love to get
have
him out
us
here
chime in
in front
via.
of a security
I
canyon and a
cannot
number of other
believe-
people. So
I can't believe how well this code demo went. Even like the small follies that actually work. That shows you
So-
sort of like how well. I mean, as ugly as the command line thing is, this is usable today.
So to keep in mind, this I see IPFS right now as where Git was prior to version 1.7. Git was around, it was larval, it was, if you were sharp enough, if you understood the system well enough, you could do some really cool things with Git even prior to 1.0, but you had to really understand it and the tooling was awful. And then as more people got interested, they started building more pieces. And now as a version 2, it's relatively easy. The command structure is still not perfect, but it's relatively easy to find your way around. So I see IPFS at the same level
Here
of maturity.
is all of the
everything
commands
is
you need
there.
to know to use
It's just not
IPFS
polished.
as a master. I know most of them. IPFS add, block get, block put, block stat. That's a plumbing command. Bootstrap, that's to add nodes that you're allowed to find peers from. Cat, which just dumps stuff to your command line or whatever's asking for it. Command is actually a list of commands with docs on all of them. There's config set, which allows you to do things in that config file I showed earlier. Replace show daemon, which you want to keep running in the background while using it. DHT tells you information about the DHT network. Find probs will actually tell you who has what resource when you ask for it. Find peer will let you find the IP address of somebody's public key, right? Because that public key also corresponds to a peer node if you're online.
Yeah.
Query, I can't remember. Diagnet, get ID, init. Again, we did that once to initialize your key. There's log level, log tail, ls amount being published. There's
So- That's pretty impressive. So what's missing at this point, from where I'm sitting, is all the basic low-level plumbing stuff is there. But what's missing is the higher level identity management, data assurance stuff. One thing that in my project, the Nebula, that I've been looking at is Freenet has been around doing some of the same stuff as IPFS and operational for 15 years, and it existed even before that. So there have been prior art systems that have done a lot of this and have not caught the level of attention, have not really caught on in any meaningful way. And Freenet has some other issues. It's just a little harder to use because of the priorities. Yeah, and so anyway, so what's missing is some higher level stuff. And in Freenet, the whole point is plausible deniability. But what I want, and IPFS has some of the tools to build, but it's not easily integrated yet. Let's say you have pictures of your kid and you put them into IPFS. And one of the problems is like Freenet has LRU eviction. So if no one visits those for a while, those will fall out of the network. So IPFS gives us this ability to pin objects in its data store. And that's great, but that's still looking at a one node level.
Yeah.
So what we need is something above that, a framework to manage that data across all of my nodes and to make guarantees to say, these are pictures of I can't go back in time and retake these. They're really important. So I need to make sure that, and then actually Git Annex already has this. So Git Annex has the ability to say, maintain at least 3 copies, at least 20 copies. And what I'd like to add on top of that, if you add some geodata in there, is let's be able to guarantee our data, say this data is really important. I require at least 20 copies with at least a mean geographic distribution of 100 miles.
And nothing really does that quite yet.
Nothing does that.
Well, you
We
also
have
have
the
to
ingredients.
trust your node and where they say they're located on the globe. There's a lot of flaws there.
But with public key identity like you have, if you know that node is owned by a family member or
It's
friend,
trustworthy.
then you can
That's
start to trust
exactly
that.
what I'm trying to do.
So web of trust. Yeah,
What I
so
wanted
that's
to
not, that's not in there.
What I wanted to
build
do
something like
was-
that.
Yeah.
Kubernetes
Exactly,
does.
because what I wanted to
In
do was
Batson,
to create a
Kubernetes
system where you would collect it, that somebody would do something, and you close the thing, run off into the desert, that you'll never get internet connection again. How do you make that work so that when people go out there, they don't know that there's no internet connection as long as you're moving around in that data set?
So yeah, these kind of ideas started at least as far back as Publius in the late 90s. And people were like, oh, you're going to enable criminals. And they said, oh, okay. And they gave up. I don't know if they were pressured by the faculty. I forget which university Publius was out of. And then Freenet made good on that, and NewNet less so. But they were again censorship resistant, anonymity or pseudonymity preserving network. So they made certain performance trade-offs. Like this is slow right now because the adoption of IPFS is not as high. So unlike the internet where you can get slashed
Also,
on
I
it,
don't know if I trust the IPFS way that they distribute their updates. It's very slow.
but this is slow right now. It will probably get a lot better.
Yeah.
Exactly. So as adoption
It's very
rises,
early.
one of the beautiful principles of distributed systems is the more adoption you get, the better it works.
And this is all aggressively open
Versus-
sourced.
Yeah.
I mean, they have JavaScript clients, Python clients.
Yeah. So, which is completely the opposite of right now. We have to scale systems and have excess capacity in the standard telephone system model, where if everyone's look at when there's a natural disaster, everyone wants to call their loved ones, make sure they're okay. The system just falls over and crashes, and no one gets to call anyone. It essentially DOSes
Well, what
itself.
they're doing now is that they're
So-
able to stop all calls from coming into a disaster. You can only call out.
Yes.
You
So,
know that?
so
Get
they're
back to IPFS.
they're inducing a failure mode to prevent another failure mode. So the great thing about distributed systems is as you add capacity, it grows. The more nodes want service, each one provides service and adds service. So the system organically scales and you don't have to do as much capacity planning. There's still some issues there, and there are still failure modes where you can have, if everyone goes for one resource that hasn't been fully distributed yet, you're still going to have contention issues. You're still going to have a momentary DOS. But overall, you eliminate a lot of the failure modes that are so common in today's
Because of the way it
infrastructure.
works in IPFS, if everyone's swarming one thing, it works like BitTorrent. They're supposed to ask for different chunks based on like their peer identity, take a hash of that. Okay, I want first and seventh and ninth chunk, and odds are the person next to me is going to have a different hash.
So I
like
actually-
fourth, seventh, and
I was working on an algorithm
Yeah.
since Nebula was about sharing Git repos to take all the repos you know about and all the objects they have, all the commits they have, and figure out which commits were the most scarce and ask for those from those nodes and exclude those nodes from the remaining pool. And as you get to more and more common nodes, it's easier to get more sources, and you care less about those because you want to get the scarce ones right now
Yeah.
because their availability is low.
that should be built into the swarm and Git
So-
utility of whatever your backend
Yeah.
is. You should not try to implement that on a front end or client scale. It
No,
should
this
be
is for the back end
built into
transport
protocol.
for Nebula for
So
version.
BitTorrent had solved that problem. Now there's separate torrent clients that don't play nice, that get things sequentially, mainly video, so they can
Yeah.
stream them. but that's detrimental to the swarm. So yeah, swarming in general, that's the problem they're trying to solve. Anyway, so I got two more things to show.
Before you go on, I just really like to highlight that a lot of what you're seeing here is completely 180 degrees counter to everything we've been used to before.
Yeah.
Oh yeah.
Like well, it's not a
Publicly, we've seen all this before, but like many other superior technologies, it's not caught on in a meaningful way. Where there's some amazing technologies like dependent type systems and all kinds of amazing stuff that's always this little research niche thing. And this is why I'm really excited about IPFS, is because unlike Camly Store, unlike NewNet, unlike all these other slew of systems that have tried to do the same thing, they're actually getting some traction.
Yeah.
People are actually, for whatever reason, catching on and saying, this one is good. We should look at this.
This one in particular is good because you can use it in the browser, you can use it on the command line, and you can mount it as a file system. All three of those things give you a gateway into all kinds of
You left out though, my favorite thing is they're clearly thinking after the Stanford talk. That one impressed me the most. They're thinking about forward compatibility. By using multi-hash, they're not tied to SHA-1 like Git. They're doing just a ton of stuff in here that they're clearly saying, we want this to work for the whole world and well into the future. And we're making all these parts modular and swappable. We know this stuff is going to go out of date. And so we have a clear path forward to deprecating and moving to newer technologies as necessary. And that's something that a lot of projects are totally missing. So
what is the killer app that's going to drive this?
Well, before we get into killer apps and all that stuff, that's what there is to uncover out of this little seed community here. I mean, we're sitting here on a Saturday afternoon, beautiful day in Phoenix, Arizona, and there's less than 10 of us here. And we're talking about stuff that, in my view, is as revolutionary as the internet was in 1995.
Yeah.
I mean, this whole place ought to be standing room only right now.
yeah, you got to remember though, this is Phoenix. There's a lot of other stuff going on. There's the
Well, the problem is this
well,
isn't
that's-
shiny enough.
but
You need a shiny object.
the
to go
point
with it.
is when I go to a meetup like OWASP and there's 40, 50 people there, and I say,
Also
how?
has a huge parent though.
Yeah, well, whatever.
Yeah.
Whatever. The point is, I mean, this is a repeat phenomenon. I go in and I say, okay, who's heard about blockchain? And I get maybe 10% of the hands go up.
Yeah.
So all I'm saying is, whatever prompted you guys to be here today,
Spread the word.
well, not only spread the word, but this is more than just some sort of theoretical, something. This is a complete paradigm shift.
Yeah, but so we're basically all pioneers here. What you want to do to fill the room is when somebody like a Fortune 500 company puts out an ad for a job saying 3 to 5 years blockchain experience, then you're going to start seeing people.
Well, that's coming.
I wouldn't even
That's
answer that
coming
ad
on.
myself.
I don't really care about filling the room either. In 6 months or a year or 2 years from now,
You want to move
the
it
room will be
forward.
filled.
You want more
I
pioneers.
might not be here, but the room will be filled. All I'm saying is, for whatever reason, you folks gathered here today and invested your time and your attention, and I'm just highlighting that this could pay off very nicely.
I've got two short details about IPFS to go over, and one medium-sized detail about this thing I just loaded up, which makes it a lot more user-friendly. You're asking for a GUI. This is sort of.
Are you in the middle?
Yeah, probably
I
should.
really want to see if that works.
No, go ahead.
I injected
Do what you're gonna
something,
do.
but
So-
this is why the in essence needed, because typing that hash in is a real pain.
Yes.
So.
Yeah. It's not human readable. So one of the details about IPFS that you need to be aware of, like I said, as you get content, you're redistributing it. You have it on your daemon, you're giving it to anybody else who asks for it. Well, that's sort of bad. What if it's really popular and you're the only guy with it? You're about to get slammed with the ton of traffic you got to send out. Or what if you visited a lot of websites and now it's taking gigabytes of your hard drive, right? It doesn't scale in that sense. My little laptop doesn't want to store 80 gigabytes of every site I ever visited into perpetuity. There is a garbage collector built in here, and it's configurable. And I think by default it's set to 10 gigs, right? So your daemon will, as you get stuff, redistribute what you get. Once it reaches about the 10 gig mark, I think 80%, it'll trigger something and start to garbage collect either what is the most scarce on the network, don't they have implemented yet, or the least scarce on the network, or maybe it might be an LRC, least recently used by you. So anyway, it'll get rid of it. Now, what if you have a website that you're hosting on IPFS and you want to make sure that stays available, right? You don't want your garbage collector to take your website you made, throw it out, and now nobody cares about your website. Their garbage collector throws it out, and now your site doesn't exist anymore. Permanent web, my ass, it's gone. Nobody has that hash anymore. What you do is you use IPFS pin, which says, here's my hash. I want you to recursively walk this Merkle tree, get every single thing it points to, and never ever garbage collect it. And that's what you have to do. And you have to do it manually, I think, except for this web UI. You have to do it manually, do pin add in the hash, you do pin remove in the hash. If you remove a pin that says IPFS when you garbage collect, go ahead and get rid of this if you want to. Right? Yes, it does it by default recursively. You have to disable it recursively.
Whoa.
Yeah. So yeah, keep that in mind. I think the smart thing to do is actually to first pin the Merkle tree and not the objects in it, so you have all your pointers, and then select which pointers you want to pick. Okay, so I went over garbage collecting, I went over pinning. The last thing I want to do, you mentioned there's no GUI for it. It's this ugly command line. So this is certainly in its infantile stages, and if you delve into what this thing actually is, you can see one Bennett's like name cited, a bunch of code, a bunch of debug code built in. As long as you're running IPFS daemon with its default settings, you can go to, I'm going to do this again because it changed. You can go to localhost 5001 is the port. It changes ports because this is a privileged application that's allowed to look at your config, your private key. It's allowed to do any plumbing commands at once. So yeah, you have to be careful. So we do this, and then 5001, we do type in web UI. Now this won't work on a public gateway because this is your remote control. This is your access to mess around with your node. You do this, it'll actually resolve to an IPFS node because, hey, check it out. The web UI is actually an IPFS IPNS entry, and they can update it, and it's distributed through IPFS. So here's my node info. There's my peer ID. I don't have to type in /IPFS config or IPFS init to see it. There's my actual public key. This is what this pointer hash actually points to this. When somebody gets this, they're finding this, and then they're verifying the signatures against that. There's all the network addresses. You can access this machine on IPv6 at this address. That's actually any address. IPv4, localhost, IPv4, and apparently the public addressable IP address of this machine. We can look at connections. So how many peers am I connected to? And under the hood, this thing is actually just using the find peers thing. I have no idea why this is not moving.
Because you don't actually have any peers like configured, set up.
No. It uses.
Oh.
So I'm connected to 92 peers on the network,
Sweet.
and it'll show them on the globe as little blue pin marks.
How,
Wow! And I can see their IP addresses and how
when,
they're sworn. That's
when did
great.
you connect to those 92 peers?
Yeah, I know.
When you started the daemon.
So when I started the daemon went out to the known peers, which are probably just IPFS's website. They're called bootstrap nodes, and said, "Hey, I'm connecting. I'm new. Here's my public key. Can you tell me of any more peers?" He says, "Yeah, here's a bunch of IP addresses. Go talk to them." Then you go talk to them, and they tell you about their peers. And you do that up to a certain threshold. And usually the threshold is A, n number of peers, and B, n number of peers distributed in a certain way across the globe. This thing obviously knows what these IP addresses correspond to on the globe. So I'm connected to these guys in the US, these guys in Europe, and there's one guy in South Africa. He's always there. I think that's actually one of the IPFS main nodes that they have listed there. Some little guy here, and those are those nodes. And of course, these are probably stacked. There's probably
That's my grandmother's house.
anyway, so you can look at your connections. This is the GUI, right? Now you can't do anything too fancy. Like you can click this, and it'll tell you all about them. There's the public key. I can click this guy.
So did you get a directory of what they have? Basically, like did you do an?
I can actually do their peer ID
Yeah.
and go IPNS and see if they publish anything. They don't have to, right?
But that's how you would.
But that's one way you could do. Yeah, I could actually ask IPNS every one of these peer IDs to see if, hey, who has what, right? But that won't tell you what they have pinned.
Right.
Now there is a plumbing feature called IPFS find probs, which you can give it a hash that says find me all the people that'll give you this back. It's really buggy right now. But that's how you sort of guess it, who has your stuff.
Is that everyone in the IPFS network, or is
Right
that just
now,
like
I
the
don't
most
think so.
closest
I
95?
am like almost certain that it limits itself, although 95 is a weird number. I'm guessing the threshold's 100, and it's actively like removing peers that are going
It could
away.
also be dynamically.
One of these in Chicago is like a VPS node I have that never turns off and just.
Because Freenet used to, so Freenet's got several things. It used to used to be like a maximum of 20 nodes, and then only
This is
relatively
all
recently
changeable
did
in
they up it.
everything.
Well, they limited. There are certain things too. When you have a network system, the more nodes you connect to, the more overhead you have. So you want to limit it. You don't want to connect to everyone because then everyone's just going to be talking and chattering. You're going to get a ton of collisions. It's actually going to hurt the network.
Because this is such an
So-
infantile protocol, they want you connected to as many peers as they can to make sure it's very strong. They're not gonna say, oh, we're super confident in the network. They're gonna be conservative and have everyone connect to as many people as they can by default. And also hold 10 gigs of storage, that's default, that's the sort of.
So it's point to point when we connect to a peer. It's not like you use one peer to route to like forward to another peer.
What's interesting about IPFS though specifically is notice this will happily use IPv6 and IPv4, and if you link it to the Tor network, supposedly, it'll talk to Tor nodes too. So it can be anonymous if you want to. You can put it on a mesh network as soon as they implement that protocol. And you can throw any protocol you want because all it wants is data that it can hash and check and verifies what it asks for.
But
So it doesn't matter if it's V4, V6, Onion, Tor.
But when it goes to crawl like a specific hash and it hits one of those peers and it finds that that peer doesn't have it, does that peer then forward the request to one of its
You need
peers?
to look up
DHT. DHT and category, you don't understand it, but if you look it up, that tells you all about the way they implement that. It's been a problem. BitTorrent sort of solved it with their DHT and again category. And these guys are heavily knowledgeable about BitTorrent and category, and that's mostly what they base it on.
Okay,
But
so
you specifically need to look up DHT and category. If you're interested in that, there's a very big rabbit hole to dive down. To tell you all about how these implementation details happen.
so there
If
is a
you're a front-end
possibility.
programmer, this is all heavy backend.
So there is a possibility that you could be searching for a node or searching for a hash that doesn't exist if it's not on any of those 95.
Yes, and it has to go ask everybody before it resolves, hey, this isn't on the network. Now, there are ways that it can quickly sort of determine that, but quickly is a loose term.
Right.
It scales to how many nodes are on the network.
Since it's 95
Again, if you're
TCP/IP
using it
calls.
the way you want it to, what you're doing is you're adding resources to the network and you're putting them to guarantee that at least from you, you'll be able to get it.
Yeah.
So if you have 5 IPFS nodes, because you have a big site you want to clear, and you pin it, as long as not all 5 of those nodes don't go away, it's gonna be accessible, right?
Right.
And anyone else accessing your data is also gonna be restricted, but what are the odds you're 5 pins? But the nice thing is all 5 of your nodes don't have to be completely stressed because you're offloading some of that to all your peers. So if some guy in Asia got your resource and you have no servers in Asia, everyone in Asia is gonna start getting it from him, and it's gonna be like sort of this viral effect of, I don't have a server in Asia, but my site runs fast in Asia because it's popular.
Even though you don't have connection to that site.
As long as somebody in Asia can get the content addressable hash, they're now on this server. Alright, so, that's the connections, files, you can actually drag and drop files here, and it's slow, but it will eventually add the thing I just dragged and dropped, tell me the hash, and it's now on the node, and I can click this, and it'll go to it, and I can copy and paste this link to somebody else, so you don't have to use the command line anymore. Pin, these are everything I have to pin, so this is everything I've been adding. By default, when you add something, it's gonna pin it because it wants to, if I purposely add it from my machine, I must want it on the network. Again, extremely public network. If you put anything in here that's private, you can't take it down. If anyone retrieve it, they have a copy of it, anyone else can get it later. So if you join with us, don't start putting stuff you don't want public on here. You can look at the DAG, which will give you any of its links.
Hang on.
Raw, it'll look at, it'll
Hang
look
on.
at the hash.
Before you move on, let's make that really clear. IPFS does not handle authentication, authorization stuff really at all right now. So when you put stuff in there, yeah, well, according to the Stanford talk, they're basically saying bring your own encryption. So if you want to post confidential data, there are kind of some early provisions. You have to encrypt it before injecting that
There are no
block.
go-to implementations. You're gonna have to roll your own crypto
So
essentially.
do not put anything you don't want to be public in IPFS right now.
If you're hosting a blog, A-OK, right? You want it publicized to the world. You don't want to host your AWS API keys there that are unencrypted. Because someone's gonna find them and go, oh, cool, I can start spooling up servers to.
So what's the difference between raw and DAG?
Again, so they're forward
This is
thinking,
all hashes.
but consider this right now only a replacement for the public web.
Now,
Only.
there is encryption when you're talking peer-to-peer. When I tell a peer I want something or tell me your nodes, I'm using his public key that he gave me. to ask that question, and he's using my public key to answer that question. So that's where there's encryption. Node to node is done. They don't know if that's solid enough. It hasn't been audited, so don't depend on that.
What's the difference between raw and DAG?
So raw will say, spit me out all the content that's in there. DAG will say, show me the content if it exists and all the links to the content. So here's this DAG. I didn't know what it was when I clicked DAG. Here's the object links. Well, this must be one of my directories that I added early on. So if I go back, but if I hit raw on that, I think it was this. It's gonna look this, I guess.
So those directory
This
hashes,
gives you a GUI to actually like explore
right?
all of this stuff.
But like those hashes that point to quote unquote directories, those are under the hood. I assume like a JSON object that have like a
You
name
can
to.
actually ask for it as a JSON object, and then we'll get it back to you.
Okay.
It's part of like there's a port 5001 REST API. Where you could say I want a JSON representation of the LS on this hash,
Right.
and it'll feed it back as JSON. So you can build applications on it that way. What's more is if you build the command line and write shell scripts or something, you can also ask IPFS, LS, whatever, and then parse what it spits out.
And that's where the Merkle DAG works, in those directory objects.
And when you ask for a Merkle DAG parent, it only knows about its immediate children.
Right.
And the things under it know about its children, but the thing above doesn't know about it. It just knows the hash that points to it.
So you can't traverse from
You can,
root
as long as
to
you can.
child.
So basically what I'm saying is if you access a root directory, you don't necessarily have all of the children yet. You have to access a folder, which is another parent, and get all of its contents.
Right.
So when you ls a directory, you're not asking for a list of everything recursively in there. You're asking for the shallowest copy of ls you can get. So that's by design, because imagine I made an IPFS node with like 1 million directories. I said, hey guys, IPFS ls this. It's gonna flood your garbage collector with this garbage data. Affect all your stuff and make you slow. So smart implementations will use the plumbing commands. If you're building a client or application on this, you'll object stat a hash, which will tell you here's how many links it has. Here's the raw file size of this hash, rather than all its children. So you can sort of get a look ahead without getting the whole object of what you're getting yourself in for. You don't really have to worry about that unless you're using other people's content and you're worried they're going to flood your trash. And so there's an all button, and it'll show you all local files. And then there's logs, and it's broken. And that's it, guys. This is all of IPFS. There's I button, node info, is to tell me all my stuff. But yeah, so this is the closest thing you get to a UI right now. And again, that's localhost port 5001/web UI, and you'll get this. And again, you can drag and drop folders to this, which is a lot more user-friendly than IPFS add. And it'll take forever because there's no threading or web workers implemented in this. It's terribly slow, but it will eventually go.
I think somebody mentioned that there's you want to specify like the algorithm used to generate the hash, like SHA-1/hash
So,
or
That's-
something.
that's not used now.
Multi-hash implementation can do that. I don't have full confidence that's actually implemented in any of their clients yet. But the specification for the multi-hash is pretty solid. One vet wrote that well before I think he did.
But why bother if it's just supposed to represent a string of random?
What if SHA-256 ends up not being secure? I can arbitrarily make anything be a certain IP or a SHA-256 hash. Then I could what's called a pre-image attack. I guess that's not a pre-image attack.
No, no,
collision
I
attack.
think it is. So
that's
pre-image.
what you get with it. If you give me a SHA-1 hash, and you give me about 2 days and a graphics card,
Right.
I can generate an arbitrary binary that's actually malware that is the same SHA-1 hash. It's not secure anymore. SHA-256 might fall prey to that in the future. So they made it modular. So if SHA-256 dies, we'll move to SHA-512, and we'll all have to convert our hashes over, but at least we won't have to update our IPFS version necessarily.
So the
And
key
you would,
thing
because
is
they don't have it implemented yet.
the address space, because it takes that into account. You can mix all the different types of hashes as we add new options, SHA-512, et cetera. They can coexist in the same space, and you don't have to type in like /SHA-256/ that thing. You can just type it in, and that's encoded in the multi-hash signature, which one to use.
As a testament to how elementary this web UI is, and it's in its infancy. If you got files, I said, oh, you can drag and drop stuff. I drag and drop that folder. This browser was frozen like forever. It's very slow. I don't think Juan Bennett is a super good front-end programmer. I'm sure he's accepted all requests, but, yeah, I mean, he's implementing web workers there and threaded out.
Let's not blame it on him. He's pretty sharp. Let's blame it on Go. Let's rag on him.
This isn't Go. This is actually JavaScript in
Oh,
the
is it?
browser, taking it,
Oh,
hashing it.
good.
Yeah,
Let's
this
blame
is
it on
like
JavaScript.
implementation.
If Juan was here, you'd be saying, hey, how about some front-end developers give me a hand here?
Yeah, that's, if you haven't noticed that Web UI is all 100% Bootstrap and React. If you know Bootstrap and React, you can actually contribute to that. There are a lot of low-hanging fruit pull requests if you want to start becoming part of that project. The
Nice.
Web UI specifically.
Yeah.
So, anything else, Christian? That's awesome.
I was
That
gonna-
should be everything. That's pretty much everything I know.
I was gonna
about
say pull up
IPFS
that file,
shown.
but I can't get it. I'd rather not type it in because that is a long hash, and the Bluetooth is all wonky on Macs. It won't transfer properly. So anyway,
Um,
oh well.
I think this is my last question until like a minute from now, but
That's all right. I'll be here.
um,
Okay.
for storing the hash of a parent inside of a child, does IPFS
You cannot do that.
You can't.
I mean, I'm sorry, the reverse. Storing the hash of a child and a parent. Is there? Does IPFS force you to use that directory object as the only means of doing that, or
So-
can you have like miscellaneous data and then you stick it inside
so,
the?
So
Sure,
under
but-
the hood, and I mean this is
Go for it.
really under the hood. There is a template. They call it a template for directory objects called Unix FS, Unix file system.
Right.
And when you want, oh man, I'm gonna have to like go into this.
Like, what if I want a Merkle DAG of just JSON objects? I want to say this JSON object points to
Well, you
a
can
hash
just-
inside
you can
this.
just make a directory with .json objects and publish that. Right, that's the easy way to do it, is just to do it the way I showed you. Just make a directory with the JSON objects.
Right.
Now, if you wanted to do it programmatically, right, there are REST APIs where you can post something and it'll give you back a hash. And you can, there's a command called object patch. I am not in the right directory. Oh, man.
Pro tip.
Object
Oh,
patch.
you did that wrong.
Yep.
So pro tip, what you should have done right before you started typing this is get the absolute path and just set up a temporary alias to the absolute path of your IPFS binary.
So,
Show you to do that next time.
the IPFS object patch subtree of commands, these are the plumbing things. You can create a
Okay.
blank directory object, an empty directory. In fact, this is how you get it. I want an IPFS object that's a new Unix file system directory. If I type this in right now, with a dot slash at the beginning, this is a blank Unix directory. If you visit that hash, it's an empty directory.
Right.
Now I can start to patch in new stuff. I can do another file system directory, and look, it's the same hash. And I want to add, where am I?
Like foo.
If I want to do
foo equals
IPFS, add
bot.
IPFS, right, I'm adding this file right now. This is the binary. I'm just adding that, right? This gave me back this object, right? And I want to put that in this empty directory. I can do IPFS object patch. Oh man, tell me the syntax because I always forget it. This is terribly not user friendly. So you use IPFS object patch add link. IPFS object patch. You need your root hash. So this is my root. And then I'm gonna name it. Is it name first or ref? Name. I'm gonna name this IPFS, and I'm actually adding this file to it. All right. This is super plumbing like oriented, but bam, that's failed. IPFS patch. Oh, I need to do add link. See, this is why I hate the command line interface. It's just a big string of just gobbledygook. But okay.
So basically, you can take a pre-existing hash and append data to it, but
yes,
that
you'll get a
appending
new
will
parent
give
hash.
you a new hash.
Right. So this is my root hash, which is the blank directory. This is the thing I'm trying to add. I give up. Basically, I got this.
So-
one.
It's a thought that counts.
Hang on a cat, but why? Why would you want to do that? They've already given you stuff so you can add a directory
so
tree.
you can programmatically generate sort of like a
Just-
scraped website.
Maybe you
or something.
don't. Maybe you don't want to use
I've
it.
actually used this a ton, Elio.
Okay.
Massive ton.
No, but I'm asking, why are you asking if you can arbitrarily reinvent what they've already put in there?
Maybe you don't want to use IPFS for storing for files. I mean, what if you want to use IPFS for
Like a key value store.
like a key value store, like
Sure.
Redis
You
meets-
you can implement
Yeah.
other stuff on
That's-
top
I've
of
done
it.
that. I've already done that.
I would not recommend it unless you know what you're doing and you know there are clear advantages to making a brand new thing.
Right.
Just implementing a new way of representing trees in IPFS, I would say don't. Why would you do that? Why would you fragment it if there's not an advantage?
Right. Like there's nothing in IPFS.
So
Why don't we
just as a general computer science thing, if there's an advantage, make a new one, but otherwise leave it alone. So
Try to do the thing he asked, but I'm fine. I can get it done. It's literally,
I think
this is super advanced.
we'll give you a mulligan on this.
Good job.
Yeah, awesome. Very cool.
yeah.
Yeah, that was really cool. So, any questions? Any comments, questions, suggestions before we wrap up? I think we're gonna wrap up early today. That was really
Okay.
awesome.
Yeah.
Sorry it took so long. I just thought-
No, that was a really extensive tour of IPFS. Thank you.
Is someone prepared to talk a little about Ethereum and the role that they feel it would play?
I think that's kind of a lengthy. What do you know about Ethereum?
Not enough to posit.
I don't
So
like criticizing-
I'm glad to wait till I'm done for the next time. That's
Okay.
fine.
Likewise.
So I think
No, I was saying I've only criticized from a distance too. I don't know. I know the
Ethereum is a
overview.
very ambitious project.
And a great marketing name.
Yeah. And
Yeah.
it's got a lot of
Yes.
parts to it.
Okay.
I mean, you're talking C++, Go, Node, a whole bunch of stuff. And it's, it's certainly commendable, but it's like blockchain 2.0, 3.0. And we're still trying to get our arms around blockchain 1.0.
I'm good then.
So-
Jay.
So anyway,
I do a deep dive on it, but I don't feel that it's fleshed out enough to actually use. I can actually use IPFS in production, no problem, if I want to just distribute, say, encrypted config files on all my nodes. I start up Docker containers and point out that hash, and bam, as long as they have a copy of IPFS, I can get it. Ethereum, is the assembly language going to change? Are the nodes going to change? How are the miners going to change? Is there arbitrary code execution vulnerabilities? There's a lot of reservations I have on sort of a distributed VM is what they're doing, and that sort of scares me. What they're doing is very ambitious and commendable, but I have a lot of reservations about if they're implemented right, it's a disaster.
yeah, I mean, don't get me wrong. I think Ethereum has a ton of promise. So anyway, so you guys are getting cards right now, kind of reminder cards. The next day long event is going to be April 30th. We're going to have a monthly meeting here at Gangplank on February 24th. I'll put that on Meetup.
Guys got the card.
Please, if you're not signed up yet on the Meetup site, go to meetup.com/desert-blockchain, and then you can follow along via Meetup. And there's a link on the website to the Meetup location as well. So, anyway, I hope this has been interesting. You guys.
Thank you very much. Thank you.
Yeah, you're welcome.
Also, I have like
You're welcome. So thanks for coming, and please tell other people you think would be interested in this. Let them know. The idea, again, we got 3 objectives: community, education, and innovation. So that's our goal.
Also, there's the Desert Blockchain on Slack.
Yep.
And is there a wired network that is public here?
I don't know.
What, you like Ethernet
You're
port?
looking for an Ethernet?
Yeah, I've got my virtual machines tied into a bridge. And of course, when the plug doesn't have a cable in it, the bridge doesn't work.
We do have dial-up here.
Ah, 14.4.
If you're on split deals, there's something called a travel router you can buy for about $16 when it comes up on sale. There's like a Hutu or whatever, and you log into it. And it's a Google, and you say, this is the SSID, this is the password for security, and then you can plug in, and it acts as sort of like a Wi-Fi to Ethernet bridge.
Yeah, and the only thing is, bridges won't typically connect to Wi-Fi nodes in a system. But yeah, I've got a BeagleBone. I've got a BeagleBone Black. And I can use that.
Okay, so thank you for tuning in today. I hope you found this valuable, and please continue to follow the desertblockchain.com website and related events. Have a great day.
Signing up.